Hey guys, how's it going? My name is Jeremy. I'm one of the guys here at Flyin Miata, and welcome to another FM Live video. And today, what we're going to do is we're going to have just kind of a casual conversation talking about engine builds, built engines, why you might do certain things, what to expect, et cetera, just kind of the basics and some overview stuff. Try not to get too deep into the weeds today so that it's, digestible within today's video. And then maybe in the future we could get more in depth if we had more questions and things like that. So let's get started with some basic stuff. And also, we always love hearing from our audience. If you guys have questions as we're going, put it in the comments in the chat. If we don't get to it in the video, then we'll try to, respond after the video when we get it up on the YouTube and all that, so that one way or another we can get back to your questions. So, engine building basics. What exactly is an engine build? Also today, we're going to focus on the B6 BP platform because those are the engines that most people are building for track days, racing, turbos, superchargers, horsepower, high compression, things of that nature. Of course, it is possible to build the NC and the ND, but the vast majority of guys are doing the NA and NB, and that's also where we have the vast majority of our experience. So we're just kind of going to focus on those guys today. What's the purpose of doing an engine build? So here is a BP. This is a 99 BP4W. And then over here in this car in Pokey, we've got a VVT engine, a variable valve intake timing 1.8 engine, both 1.8s. But the 1.6 architecture is basically the same thing. So, anything you say there is going to kind of cross over. These engines, one of the reasons that we've always done so well with our turbo kits is because originally the B6 engine started out as a turbo engine in the 323 GTX, and it was, homologation for rally and that kind of thing. So it was really a fairly overbuilt engine. They stretched it out when they went to the 1.8 BP, ended up in the Miata without a turbo on it. And so you've got this overbuilt engine that's got this, this lineage from the turbos and stuff. It ends up in the Miata, and then Flyin Miata develops a turbo kit back, around 1990 or so, and it's, the rest is kind of history. So we are starting out with a mill that is fairly robust and definitely overbuilt by today's standards. However, there is still room for improvement depending on what your goals are. So, we've always had turbo kits, and the vast majority of the turbo kits that we sell are designed to be long-term reliable with a healthy stock engine. And over the years, we've had lots and lots of customers who wanted to take it even further. So, with our stage 1 turbo kits that we're currently selling that are 50 state legal, those are going to take it up to, 170 to 190 wheel horsepower. No problem, long-term reliable. When we used to sell the FM2 turbo systems, where we had the standalone ECU back, in the old days, and a lot of guys are still doing that by procuring the standalones elsewhere and then doing a turbo or supercharger. You could generally run, rule of thumb around 250 wheel horse with a good calibration and everything else done correctly and have good long-term reliability. But there's always guys that want more. Here. So in order to take it further and have good reliability, because what do they say? What is it? Cheap, fast, or reliable, pick any two, right? So in order to take it to that next level, if you want to get close to 300 wheel or beyond, then you're going to have to do things to the engine. You're going to have to build your engine, right? So what does that mean? In terms of the Miata platform, generally what guys are talking about is you're going to go with a few key things that are going to be necessary. So I like to break this into kind of the meat and potatoes, and then you've got the icing on the cake. So that way you can work on your budget. If your budget is, unlimited, do both, but if your budget is limited, you want to at least focus on the meat and potatoes. And, and also these are things that we've just learned over the years, building hundreds of these engines for customers that we've installed here at the shop, or that we've shipped out to customers that installed them themselves. And also, many, many more customers who we've sold the parts to that have had this stuff done locally, because we're not building engines in the house anymore, but we are still selling all the parts so that you can have your local machinist do the work, do the assembly, et cetera, et cetera. So here's the starters. The rods, the pistons, those are the two things that everybody really knows about that are going to be failure points. Anytime you're increasing your horsepower, you want to ask yourself, all right, where I am now, what is my weakest component? What is going to be my next mode of failure? address that, and then, what's your next mode of failure? Address that, and just try to build up to these higher and higher horsepower levels if you want it to be reliable, which you should. And the places where we're going to start in a forged engine build for a B6 or a BP for higher horsepower levels primarily with a turbocharger. It's not too many supercharger guys that are getting to these levels. Some, but not many. But lots of turbo guys. Starting with rods and pistons. So the stock rods are a cast rod, and we upgrade to nice forged rods, and we use Carrillo rods. There's a couple different geometries that we've always had. We've had an A-beam that kind of turned into a super A-beam over the years, and then an H-beam, which is beefier. So, for example, if a person said, well, I want to do a 300, 350 horse car, A-beam rod is going to be fine. If I want to do a 400 plus horse car, I would probably go with an H-beam. Or if you're the kind of person that just wants overkill, just go with the H-beam. And I will also mention in there having dyno tuned many of these turbo engines that we've built like this. I would go with an H-beam because I tend to see on the dyno a more robust top end with the H-beam engines when we're building all the stuff the same than with the A-beam engines. And I can't really quantify that, but it's a pragmatic thing that I've seen on the dyno for years. So you have a forged rod. You also have a forged piston. We have a forged piston that Wiseco makes for us. It's custom made to our spec. 15 years ago, we started with the Wiseco off-the-shelf spec for their piston, and then we said, well, we want to improve this or we want to improve that. We want to go to your better quality rings, and we want to get the valve relief ideal for up to a +2 millimeter valve. We're doing +1s, but some guys are doing +2s, so we want to get that valve relief correct. We want to get the compression ratio and the compression height correct for what we're normally doing. We want to get the taper on the skirts just right because we want our pistons to be relatively quiet. And the vast majority of the engines we've built with our current generation of Wiseco pistons, they're really not that noisy cold, whereas a lot of forged pistons are pretty noisy when they're cold. We want to do a ceramic crown coating because this is going to give more detonation resistance, etc. And we want to do this. It's a Xylan, some Molly people call it, but I think Wiseco calls it a Xylan skirt coating because it just kind of eases the braking. ultimately this is going to wear off with use, but it's just going to kind of help the braking process. So, etc., etc. Over the years, we've developed this. 10, 12 years ago. For example, the skirt was, a nice round skirt. And then we started realizing on the 350 plus horsepower cars, we're actually getting some cracking here. And so around that time, Wiseco was working on the strutted forging, and we went to the strutted forging, which was much, much stronger. So moral of the story is it's a piston that we've really developed for a couple decades now to being what it is today. So you've got your rods, you've got your forged pistons. The next thing you're going to look at, and this part is simple, is your head studs. On the factory engine, it uses a head bolt, and also on the main caps, it uses a main bolt. When we do a rebuild, we use head studs and main cap studs from ARP. They're much stronger. We've worked with them to kind of get the torques exactly where we want it. And we actually, for the most part, use a factory head gasket. One of the things that we've learned is a factory head gasket with ARP head studs is going to be fairly reliable up to around 500 foot-pounds of torque, which is more than the vast majority of people are ever going to see. So, the time where we would use on a BP, on a B6, we're always going to go to an aftermarket gasket because the B6 gasket is composite, whereas the BP head gasket is multi-layer steel. So we always would use a multi-layer steel in any case. Where we would potentially go to an aftermarket head gasket on a BP is if you've had a head or a deck shave in order to maintain your compression height. Because on your compression height, it's important to have a certain amount of gap there so that you have an ideal combustion. So if you have a shave and all of a sudden your piston is a little bit proud, then in that situation, we might need to go to that thicker head gasket in order to get the compression height just right and get your squish area within the tolerable range of squish that we want to see for ideal combustion. So little things like that. I mentioned the main studs earlier. We do main studs in all of our builds. Truth, they're not really necessary for the horsepower, but as far as a complete package, we like doing it anyway. Whereas the head studs, yes, you want to go with the ARP head studs, and we do the main studs because why not? We're in there anyway. And you know, who wants to reuse those bolts? They're old and smelly at this point. You know, a head or a main bolt's about the smelliest thing you can pull out of an engine. So if you haven't tried it sometime. Okay, so on the top side of the engine, you know, some other things we're going to look at are the valve springs. And on anything that we do here that's going to be a higher horsepower engine, that I do consider the valve springs to be part of the meat and potatoes. And there's a couple different options. Historically, we've almost always used, well, we've all used SuperTech springs, and we've almost always used the single springs for a street car. You know, for cars that are 350 horse or so, it's fine. Now on a track car, for other reasons having to do with the valves, you know, we would recommend the double springs if you're doing high horsepower or high RPM. A track car that spends a lot of time at high RPM, or just a really high horsepower car, we would go to the doubles. So, you know, we have both options. But, you know, we've used the single springs for decades on most engines and pretty much all street engines, and it's been just fine. So those are kind of the meat and potatoes. In your block, you've got your rods and your pistons. In your head, you've got your valve springs. We also, we've got one on this car over here. I can take a look. Another meat and potatoes thing that I personally really would recommend and is the ATI damper. You can see it down here. Now, keep in mind, if I had a bone stock Miata and somebody said, you can do one thing to the engine, I would probably do an ATI damper because it makes the engine run so much smoother. It's really, really impressive. You know, if I'm not the guy who wants big horsepower and to do all these crazy things to the internals, I would still do an ATI damper. So I do consider that part of a meat and potatoes thing. Now inside, on your BP engine, you've got a nice forged crankshaft. The cranks on these don't break. I mean, I've heard of them breaking. I've never actually seen it happen from horsepower. But another meat and potatoes thing is to go to a tri-metal race bearing. And we've almost always used the, oh God, what is that of Australia? The ACL race bearings. They're the best. We've also used, years past, King did come out with a tri-metal bearing. That was also good, but generally speaking, we've always stuck with the ACL race bearing. At the high horsepower applications, just haven't had an issue with them. Whereas, you know, with the stock bearings, when you start to get into those really high turbo horsepowers, you know, that is something that is going to become a little bit more of an issue as well. We've never really used crank scrapers that much. You know, you could if you wanted. There's no reason not to. But those are kind of the meat and potatoes things. We generally keep the stock valve train. We've found that on the turbo cars, the stock cam profile is really pretty darn good up to about 18 pounds of boost. If we were building something that was over 20 pounds of boost, I do believe that we could do better with you know, using a cam profile that was more well tailored to those really, really high boost levels. But, you know, up to 18 PSI, which once again is going to cover the vast majority of turbo owners, we just use the stock cams and they're fine. And also remember that the stock cam profile has to follow the lifters. So between the NA cars that have the hydraulic lifters and the NB cars that have the solid shimmed lifters, they have to be paired up. So because the lobe profile does kind of match what's going on with the lifters. So if you are switching over to NB cams, you also need to switch over to those NB solid lifters. So that kind of covers, you know, some basic meat and potatoes. And as far as expectations, that's going to be what gives you a really strong engine that is going to put up with the horsepower. Assuming you have good tuning, this is always predicated on, is your calibration good? Because if your calibration is bad, I don't care what you've built the engine with, you can screw it up and it's going to be expensive. But if you have a good calibration and you know what you're doing, and, you know, a little bit of mechanical empathy, which goes a long way, you know, the expectation here is that that is going to give you what you need for strength so that you can run these higher boost levels and have good long-term reliability, which is really the goal. Beyond that, you know, you get into some, I call it icing on the cake stuff. So if you have the budget for it, fantastic. If you don't have the budget for it, don't worry about it. And icing on the cake stuff is going to be, actually, there's one thing I forgot in meat and potatoes, And this kind of has to do with a specific subset, and this is the valves. We use 1mm oversized valves. Stock valves for most people would be just fine for a meat and potatoes build, with a couple exceptions. Specifically, what we started seeing about 10 or 12 or 15 years ago was guys who were, it kind of started with the autocrossers and the track day guys who had the VVT engines who were bouncing off the rev limiter all day. They started just absolutely hammering their intake valves. And, they were using stock valves that were cut, or they were using an aftermarket stainless valve. Long story short, there's a lot that happened over the years. But we ended up going with, we had SuperTech make some Inconel exhaust valves, and ultimately also, after much fist pounding, some Inconel intake valves as well that solve those problems. So for a really high horsepower build, or something where you're spending a lot of time bouncing off the rev limiter, or a high horsepower turbo build that's running on low octane fuel, where you have to retard a lot of timing because of your low octane, which is going to really increase your exhaust gas temperature and hammer your exhaust valves like that. Going to these Inconel valves has really kind of solved the issue. You can see where the seat here is just totally hammered out. And that particular valve came from a car that was, running about 18 PSI on 91 octane. And it was a street car. So anyway, the Inconel solved that. So for a meat and potatoes build with a caveat, the stock valves are usually fine. And the caveat is those weird situations like autocrossers, track day guys, and high boost, low octane guys. So in those situations, I would say that going to the Inconel valves is really kind of a meat and potatoes thing. So hopefully that was not too confusing. So back to the icing on the cake. There's a lot of things that, the icing on the cake stuff, these are things that are going to give you efficiency. You don't need them to handle the horsepower, but so if you're on a budget, don't worry about it. But if you have the budget for it, the efficiency does nice things for you. It allows you to, general overview, to make kind of the same power at less boost, or at the same boost, make a little bit more power. And, in most street cars, you're probably not going to notice a difference. On the dyno, you might notice a difference. If you're racing, where you're being timed, you might notice a difference. So that's why it can kind of be a give or take. And a lot of that is going to revolve around things like porting and polishing and machine shop work, port matching. So when the work that you're going to do on the intake manifold, basically for the air flow. So when you smooth out the ability for your air to flow, it takes less work for the air to flow, and it's going to be, because this is just a big air pump, and the air is going to move through the pump easier if there's less obstruction to that. And so where you've got, your multi-angle valve jobs, and you've got your back cutting in the valve areas, and unshrouding and porting and polishing and things like that, mostly all the head work, deshrouding in the chamber. Well, in the chamber, that can also be kind of a detonation thing, but we'll get to that. So those things are awesome things to do if you have the budget, but it's going to be an efficiency thing. It doesn't have anything to do with, because with a turbo car, you want to make a little more power, you turn the boost up. So you can get there, it's just not as efficient. And, if you're racing, efficiency is very important, because the most important thing when you're racing a turbo car is thermal management. And so if you can be a little more efficient, then you can reduce your thermal load, which means you're going to either be more reliable on track, or maybe you can get another half a lap before you have to shut down because you're overheating. So things like that. Let's see, on the bottom end, things like a crank scraper would be icing on the cake, things of that nature. So, if you have any more questions about that, it's really, we've built so many of these engines over the years, and we've always really tried to start with having a conversation with the customers. What are your goals? Why are you trying to accomplish this? And if you can talk to us about, well, this is what I want to do with the car. This is my budget that I have, and this is the realistic expectation for how I'm going to use the car, then we can try to help with, the why and the guidance, and saying, okay, well, if you want to do this, then this is probably the build you want, and here's why. Because it's going to be, the most efficient, or the most reliable, or the most budget conscious, whatever is important for your build. So when you have questions like that, if you want to get into the specifics, that's when you can reach out to one of our customer service guys, support at flyinmiata.com, and, they can help guide you in the right direction. So how would you know if you needed a rebuilt engine? Well, for power reasons, it would be talking about just that. What are your power goals? And is what you have now going to be sufficient for what your power goals are? And if the answer is no, then you need to rebuild with forged internals. Otherwise, if you're running a modest power level or even stock, you may need a rebuilt engine if your compression's down and you're not making any power, or if your valve stem seals have gone bad and you're smoking on deceleration, or if your rings have gone weak and you're smoking on acceleration, or if you overheated and you've warped everything, or some other bad thing has happened to the engine, you may need to rebuild. For power goals, you're always going to be better off rebuilding with the meat and potato stuff. If it's not a power thing and you need to rebuild, oftentimes it's going to be the cheapest just to find a healthy used engine and drop in there, because when you're doing any engine rebuild, the labor and the time is really a significant portion of the cost. And adding those extra forged internals, yeah, it adds some cost, but it's not a huge percentage of it. So, doing a full rebuild from top to bottom with stock components, you're spending a lot of money to not have anything you couldn't have got just with a healthy used engine. So, you can make that call. It's really kind of comes down to what's important to you. But if you're going to be doing a full rebuild anyway, I would probably look at some of these forged internals, because that gives you more options down the road. And one of the best things that you can do in life is give yourself options. So, yeah, it's easier to replace than it is to rebuild, but it's more fulfilling and gives you more options if you rebuild. Best practices for rebuilding an engine. There's a lot of skill and experience that goes in. Find yourself a really good engine builder, especially if you can find someone that has experience with 4 cylinders. The people that are really well experienced with pushrod V8s aren't necessarily the people that have a lot of experience with dual overhead cam 4 cylinders. It's worth your time to find somebody that really knows what they're doing, and find a machine shop that really knows what they're doing. If you find a machine shop that says I can be done next week, there's probably a reason. Just being honest. So, find people that know what they're doing. They're probably not going to be cheap. They're probably not going to be quick, and it's probably going to be better in the long run. So, also, we do have a document that we put together that, speaking with the customer service team, actually, I think this is going to be something that we turn into a knowledge base article. If you're not aware, we have started an internal knowledge base article to try to, we're trying to take all of our decades of knowledge and distill it into some online stuff that's just kind of easier to access, because I know we're super busy all the time and sometimes it takes a while to get a hold of us. We do our best. We love you guys, and we're really busy all the time. So, good problem to have. With that, we're trying to put a lot of our historical knowledge into knowledge base articles, which you can find at help.flyinmiata.com. And I think one that we are going to do is we do have an internal document that we used when we were building engines, and it's an instruction sheet. It's a checklist. So every engine we built, we had a checklist of all the things that we would make sure to do and sign off. So every engine we built was consistent, reliable, and up to par. And there's no questions, because we've been doing it for so long. We know exactly what we need to do to get the customer an awesome built engine. So it's not there right now, but we will turn that into a document. And when we get that up, when the time comes, maybe we can go back and link it in this video. So we did get a number of questions that I want to touch on here. And then, so I'll get to the ones that some folks asked before the video. And then from there, we can see if there's any other questions today. Let's see. One customer asked, engine mods that are worth the additional effort cost versus those that add insignificant gains and reliability issues. I guess someplace I should probably step back here is I've been talking a lot about turbo mods. And to kind of round this out, let me talk a little bit about engine builds for naturally aspirated cars, because that could answer some questions. We've built a lot of engines as well for naturally aspirated cars where we increase the compression. We would take it up to 10.5, 11 to 1 compression, give or take, depending on what the customer was looking to do. Now, the first thing to know is, any engine the naturally aspirated engine builds are actually a little more expensive than the turbo engine builds because there are some extra steps involved. Such as, claying to determine if it's an interference engine when we're done and things of that nature. So cost-wise, it's a little more expensive. Horsepower per dollar, naturally aspirated mods for Miatas aren't good horsepower per dollar. They're just not. That's why our turbo kits have always been so successful, because for the horsepower per dollar, you simply cannot in no way, shape, or form beat a turbo kit for a Mazda Miata. It's just not going to happen. For example, our stage 1 turbo kit, which is, call it $4,000 once you get your stuff, round numbers. If we were to do a high compression build of an engine, that's going to be somewhere, when we were building engines back in the day, it would be somewhere between $8,000 and $11,000 just for the engine. And then you'd have your standalone, another couple $1,000s. Then you'd have your dyno tuning, another $1,000. And you'd probably end up with a little bit less power than you'd have from our stage 1 turbo kit. So, we could get these on a BP 160, 165 wheel, if we're lucky, with all the bells and whistles, all the icing on the cake, everything you could possibly do. And a BP with a stage 1 turbo kit's talking about 175 wheel. So for about a third the cost, maybe a quarter of the cost once you factor in labor and all those things. So it's just not efficient. Now, some people really want that, and that's absolutely fine. If that's what you want and that's your goal, if that's for your racing series or that's just your money, man, do what you want. It's just important that you're aware so that you can have all the information to make that decision. So as far as things that add significant gains versus reliability issues, really any of these things that you do well, there's not going to be reliability issues if you're paying attention and you're treating the engine well, you're treating it with respect, you're changing the oil. I actually had a customer one time that, we built a stroker engine and saw him a couple years later, and it's like the oil was like tar, and it's like, man, like, what do you do? Come on, take care of your engine, right? We love this thing, come on. So having that mechanical empathy and taking care of stuff and following recommendations, don't try to run 20 pounds of boost on a stock engine. Don't try to run 15 pounds of boost on a stage 1 turbo kit. Follow the recommendations. They're going to be reliable. We've been doing this a long time and we know what works and what doesn't work. So, and as far as effort, if you're building an engine, there's really not a significant amount of additional effort regardless of what you're doing. So that's why it's really important to hone in on what are my goals so that you're getting it right the first time and not doubling up on that effort, because that's when it gets expensive, is if you weren't honest with yourself or if you didn't have a game plan where you worked things out in a logical order and you've got to go back and do it again, that's when it's going to get expensive. So, but the rest of the stuff, the pieces, parts that go into there, as long as you're doing it right, it's not really a reliability issue or anything like that. And as far as value for the dollar, just, if you want value for the dollar, you just want a turbo kit. Had a question about upgrading internals and as far as emissions. Now, I'm just going to lead into that saying we don't do emissions. We don't give advice on emissions. If you do start changing your internals in terms of your compression ratio, your anything that changes the flow of air through your engine, your cams, your valves, it could affect emissions. And there is really no way to know exactly how that is going to go until you're done. So your call is really where I'm going to have to leave that question. You have to decide if the potential return on investment is worth the potential, oops, I got to go get a junkyard engine to pass emissions now and swap out my engine once every 2 years. So, decision you'll have to make. Had a question about gapping rings. I am going to defer directly to the document that we will soon be making a knowledge base article, because that document tells exactly how we gapped rings, how we set up all that stuff, how we torque everything. I had another question in here about torque specs. Generally for torque specs, you want the factory service manual. They don't sell them anymore, so if you can find one, that's fantastic. Snag it up. I think just looking online, there's probably online resources that have copies of the pages that have torque specs and stuff like that in there. In our engine build manual, we do have torque specs for some of the mission critical things, like your ARP studs, etc. But generally speaking, we would just simply follow the spec for the factory service manual torque spec, because with the exception of what we're doing with the ARP head studs, none of that's really any different. Can engine builds, how expensive do they get, and is there a cheaper option? Well, you get what you pay for. So, if you want high quality American made parts versus Chinese parts, is it good enough? I guess you'll find out. So you just kind of have to decide. One of the rules I've always lived by is you only cry once when you buy the right part. So that's kind of a personal choice. We've had engine builds here up as probably the most expensive one was probably around 11 or 12 grand for a fully built stroker with all the bells and whistles. The cheapest engine we would build here would be probably around 6 grand. That was super baseline meat and potatoes, and anywhere in between. Can you do it cheaper than that? Yes. Is it going to be good enough for what you want to do in the long run? Yeah, maybe. I guess you'll find out. So, kind of a gray area question. Valve seals. So one customer asked, what kind of valve seals do we recommend? That's actually an interesting question, because early on we had some really bad luck with aftermarket valve seals. And for a long time, really still to this day, we will only use factory OE valve seals. And they say NOK on them. That's the brand that makes the factory ones. Because they just don't break. Factory engineers make a lot of money to get this stuff right. So when you're looking at things to upgrade on your engine, there's a certain logic in if it's not broke, don't fix it. So if you want big horsepower, yes, you need forged pistons, you need forged rods, you need some stronger studs, et cetera, et cetera. But things like valve stem seals, the stock ones are going to work. The timing belt, I've never seen a stock timing belt break for horsepower. I've seen it break for age and neglect. And fortunately, this is a non-interference engine, unless you get into some of the crazy high compression stuff, but I've never seen them break for horsepower. So, and we've done a number of engines here up over 400 wheel, and we have customers that we've assisted in builds up, in the 600 wheel range. Although, we haven't had the fortune to have any of those here in the shop. What silicone sealant would we use for sealing stuff? And that's actually also a good question. There's only one that we use here. It's made by Permatex. It's called the Right Stuff. It's this black tar stuff. I don't even know if it's silicone, but anything having to do with oil, that's all we use, and nothing leaks. So recommend that stuff. Had a customer ask about sodium-filled valves. Some of you may know in the 323 GTR, they actually had sodium-filled exhaust valves. And yes, they work, because part of the thing with the exhaust, with the valve, is when the valve comes closed, you've got a lot of heat in the valve from the combustion, and you want to try to dissipate that heat as best you can through the valve seat out into the head, so that you can dissipate the heat and not have things melt. And so on the 323 GTR, they actually put sodium in the stem of the exhaust valves, and I don't know the chemistry behind it, but I know it was to help with the thermal management, and yes, it did work. We've never sold sodium-filled exhaust valves, just because getting them produced in the aftermarket really isn't feasible, budget-wise. I might have looked at it like 15 years ago. But we did end up going with the Inconel valves, and the Inconel valves really solved all the issues that we ever had with valves, and so we just stick with those. Discussing the power limitations on the stock components. We talked about that a little bit earlier. About 250 horse with a well-tuned forced induction system is about the ceiling for long-term reliability. With a turbo system, with our standard GT2560 turbo system, that was around 12 PSI on an NA and around 10 PSI on an NB, because an NB has a little bit more efficient flow through the intake manifold in the head. And that's where we would always run the FM2s. We got decades of cars running long-term like that. The other aspect of that is with high RPM, specifically with naturally aspirated mods. I got a lot of calls over the years. Oh, how do I make this into an 8 or 9 or 10,000 RPM engine? And I said, the best thing you can do to turn a BP into a 10,000 RPM engine is to sell your Miata and go buy an S2000. The BP is just not a high RPM engine. When you turn those high RPMs, first off, the strain on your connecting rods goes up exponentially with RPM. With a turbo system, you've got some back pressure that's holding it in, but there's also another school of thought that with a naturally aspirated system that has a well-tuned set of headers, that the evacuation characteristics of the pulsing of a well-tuned set of headers will actually serve to pull the pistons up. And so even if you don't have a ton of horsepower, you can actually break rods kind of from that vacuum effect of running too much RPM on a well exhaust tuned naturally aspirated system. So if I were to say, A-beam rods up to 350 horse on a street turbo car, I would not say A-beam rods on a 350 horse naturally aspirated. You're never going to do it. But if you were for some strange reason in the universe able to build a 200 plus horsepower naturally aspirated car turning 9,000 RPM, I would not recommend A-beam rods because of that effect. I would go to H-beam. But realistically, the BP just doesn't have the flow. When you see it on the dyno and you see what is the engine producing at the wheels on the dyno, even if you do all the bells and whistles and all the things, it's the architecture just isn't built for really, really high RPM. And all you're doing is stressing your stuff without actually improving your area under the curve. So not to rabbit trail too much, but on the dyno, when you have your set of things that you've built, what you're trying to optimize your horsepower, but you're really trying to optimize your area under the curve. And that can be where you can get into really useful things like adjustable cam gears, which we haven't talked about yet, or the VVT engines, which have the computer-controlled adjustable intake valve, with the downside of that being I would not run those over 7,200 RPM pretty much ever, personally, because of what we're seeing with killing the exhaust valves. But on any of the others, you can do your adjustable cam gears to try to optimize your power band when you're adjusting your cam overlap and your cam timing in order to trade low end for top end. And that's something, people always ask, what are my ideal settings? You have to figure that out on a dyno. There is no such thing as ideal settings because this is an ecosystem. This is all the things that you have put together in your particular efficiencies and your particular goals. When you're looking at your area under the curve, is it a situation where, hey, I drive on this track and I need to be able to be in my power band from 4,000 RPM and up no matter what? Okay, so then it's really important for you to be in that power band, so you might want to adjust this so you've got a nice power band squared around, your 4,000 RPM to whatever. On the street, you might want to pull that down because really people want all this top end stuff, but really the bottom end torque is really what's more useful on the street. So, that's where it kind of comes down to being honest with yourself about what your real goals are, how you're really using the car so that you can optimize things for what makes sense for you and, not kind of what pipe dreams or guys on the internet says makes sense for them. So that was a little bit of a side note talking about cam gears, which we hadn't talked about yet. But cam gears are awesome if you're willing to put it on the dyno and put in the work to get them in the space that makes the most sense for you. Let's see. Budget upgrades. Stage 1 turbo kit. That's a budget upgrade because built engines and standalones are going to cost you 5 digits if you do it right. So that's your budget upgrade. Yeah. And to kind of step back to this a little bit, a lot of people have really extolled the virtues of the VVT engine. I've never been one of those people. Below 7,200 RPM, I'm not going to get into it, but this is just pragmatic experience based on the last 15 years of tuning cars on the dyno with every possible thing that you could think of here at the shop. If it were me and my money, I would take a 99 2000 all day long because I would want to get a little bit more. I would want to do H-beam rods and build it to have power out to maybe between 76 and 8,000 RPM. You're not going to get more than that, really. But we have actually built a few cars with H-beam rods and turbos that have actually continued to build horsepower out almost 8,000 RPM when you really kind of do all the bells and whistles and get it right. And that's a really sweet setup. Most of the power is really falling off before that. But there have been a few that we've made that had a super wide power band, and you're just not going to get that RPM. For me personally, I would never try to get that RPM with a VVT. And not that people don't do it. I wouldn't do it. But, that's just me. So, and, questions about philosophy, and I've kind of hammered on this a little bit, but the philosophy is really a personal choice, and it's kind of between your ears. And that's where when you're talking to, if you call in and talk to one of our customer service guys, that's where you want to be honest with yourself. It's like with your insurance agent. Don't lie to your insurance agent, because you're only hurting yourself, because they're there to try to help you out. Don't lie to your technician. What is your honest goals? How are you really using it? What's your real budget? Because that's where you're going to get the best advice for putting together what's actually going to make you smile for the longest. Because why are we doing this? We're doing this to have fun behind the wheel. We're doing this for the stoke and the enjoyment of driving these cars that are so awesome. And, if things are breaking, or if you have to do it twice, or, if you took bad advice and you bought something, now you don't like it, that's just stripping away from the awesomeness and the fun you're having. And so, we want to try to help you have fun. That's why we're here. We want to help you to have the most possible fun you can have behind the wheel or Miata. And so if you can be honest with us, then we can try to give you the best advice we can, so you'll be able to have those great experiences. So, let's see. Engine build time process. That's where, when you're hiring people that are really good, it's going to take some time. When we were building engines here, it was average about 4 months, and the vast majority of that was sitting in the queue at the machine shop. And then once we got everything back here, we could get it built, in about a week, just, because we're busy and we got lots of stuff going on. It's not going to be a fast process, unless you're just stripping it down, cleaning it, and slapping it back together, and you just need the thing fixed and you're not worried about performance or all these other things. Yeah, you could do it quick. But if you're going to do it right, you're going to overbore, or at the very least have it honed. We would always overbore. You're going to have the head and the deck surfaced by a machinist at the very least, have the valve train cleaned up at the very least to really kind of do a nice job. So it's going to take some time. With that, what a lot of guys will actually do is they'll go to the junkyard and they'll get a nice healthy engine to toss in their car while they build the one engine, or, whatever, you got two engines, one of them stays in the car. So you can take your time to build the other engine, do it right, do how you want to do it. And you're not stressed because I got to have my car back together because I got to do X, Y, Z. So, once that gets back to having options. So spending a little bit more money there helps to buy you some time, so you can step back and say, okay, how can I do this well so that I only have to do it once, and I'm going to be the most happy in the future when I'm driving the car. Let's see. Gosh, that's a lot of information. Let's step back now and see if anything has come in live, because I could go on and on and on about this, but we want to try to keep this kind of high level and talking about the basics of engine builds, and just try to keep it condensed. So, Mike, man in the corner, do we have any live questions that I can field?
We do. So, what are our thoughts on the exhaust intake cam swap? Because that's a very common thing to do for people that don't want to build the whole engine, but they want to do a little something up top.
The question is, what are our thoughts on the exhaust intake cam swap? And I will be perfectly honest, we have never done that in the shop. We've tested lots of aftermarket cams in the shop and have almost never, ever found any one that was actually worth using, naturally aspirated or turbo. So take that for what it's worth. But we never actually did the exhaust intake cam swap ourselves. So other than what I read on the internet, I don't have a whole lot for you on that. Other than to say that horsepower with naturally aspirated modifications on these cars is really hard to come by. You can get a little bit here, you can get a little bit there, but without changing your compression ratio with your pistons or changing your cam profile, which this does address, there's just not a lot of power on the table. So, you can do intake header exhaust on one of these, and you might get 0 horsepower, you might get 10 horsepower. I wouldn't expect too much more than that. It's going to look better, it's going to sound better, but you don't do intake header exhaust mods because you want to make a whole bunch of power on these. That's where you get a turbo kit. And I mean significant power, stuff you can actually feel, like 10, 15 horsepower, and My turbo car does that between daytime and nighttime just with the temperature change. So to be fair, we've never actually done the intake. If you want to do it, great. But with those kinds of mods, there's a couple things to consider. This is important. This is important. It's what the mod does and how the mod makes you feel. And these are both important and they're both valid. So if you're interested in what the mod does, you owe it to yourself to do a before after on the dyno. If you're just interested in how the mod makes you feel, there are a tremendous amount of modifications out there, which we may discuss in another video, that don't really do anything or they don't do what you expect them to do. But they might make you feel good. And that is legitimate. That's a real thing, because ultimately it comes down to how do I feel when I'm driving this awesome car? Be honest with yourself. And, if you like me, I like to experiment. I might do something just to try it and then might do something else just to try it. And because that process makes me happy. I like to fidget and I like to experiment and I like to try different things because it builds my knowledge and it gives me the experiences. Personally, I'm the kind of person that I crave the experience more than the ownership. So, I like to learn and grow and try this and try that, but I don't keep all the stuff, Oh, I tried that. Great. Move it on. Oh, try something else. Great. Move it on. Oh, try something else. So that's what makes me happy. So what makes you happy? And so just being honest with yourself when you're doing these mods, for example, it's a funny story. Before I got into Miatas, I had a 92 Acura Integra. And man, I loved that car. And I did, of course I did an AEM intake and I did, gosh, who made those headers at the time? I don't even remember. It was a long time ago, 94. And I got a set of cams and I was going to the drag strip at the time. And I put in the cams, man, I was so stoked. It sounded meaner, rah, 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 it's so much faster, blah, blah, blah. Next weekend I went to the drag strip. I was 0.2 slower after doing intake, header, exhaust, and cams. What happened? Well, if I never would have went to the drag strip, it made me feel better. So just, be honest with where you want to go with it, if that makes sense. I took them out because I wanted to be faster, damn it. More questions?
So you mentioned earlier that the ATI damper was one of your favorite things. Why would it be beneficial for an otherwise stock engine? And then don't we only generally recommend them for forced induction or big power cars anyway?
Okay, so the question is about the ATI damper. Why would it be beneficial? And I thought we only recommended them for forced induction. Well, if my lovely CSR team is only recommending those for forced induction cars, then I need to have a conversation with my CSR team. The ATI damper, you know how a damper works, right? Super highly, there are big documents about this online. Feel free to go read it. But your crankshaft, when the combustion event happens, bam, it's whacking on the crankshaft and it's producing vibrations and harmonics. And so your damper up here, this is a really important thing. And this is why you never, ever, ever, ever replace this with a solid piece of metal. Ever. So this is a two-piece. There's an inner shell and an outer shell, and there's a rubber, the damper, the rubber piece in the middle, and it's designed to absorb those vibrations. And, it's sufficient. It's stock. But the ATI unit it's just higher end. It's well-engineered. It's tuned to be a bigger, beefier, better damper to absorb those vibrations. And so when you put an ATI damper on your engine, it turns it into a sewing machine. With these ATI damper engines, I can run them all the way out to red line and it's just smooth. Whereas with a stock engine, generally you run it out to red line and you can kind of feel a little bit. Things are kind of shaking, and it's hard to quantify, but it's just something that we've experienced on car after car after car. You put this thing on, and it just turns it into a sewing machine. So you can rip the thing all the way out to red line, and it's just like a rotor. Well, okay, maybe not rotary smooth, but it's just smooth. So that's why I would do it on any engine, no matter the horsepower level, because it makes the driving experience nicer. You can. In this car, I can drive at 6,000 RPM and it's just cruising, super smooth. Like, it's just not a thing. Whereas in a stock engine, if I'm driving at 6,000 RPM, I can kind of feel it. I'm like, I should probably shift, you know? So yeah, that's what the damper does. And that's why you want to have a really high quality damper on there. And that also, as a side effect, actually something else we didn't talk about is oil pumps. We also sell the Boundary Engineering oil pumps, which have a billet gear. A lot of guys in race applications, especially, I haven't seen it so much just in pure high horsepower, but definitely in race applications. I mean, yeah, if you get crazy horsepower, but that will shatter because the factory oil pump gear is cast. And when you're really pushing the engine hard, it'll shatter sometimes. And the Boundary is a billet unit that, it's a lot stronger, so it solves that problem. And it's fantastic. We would recommend that. Now, what I've always told people is if you're on a budget, ATI, because the ATI damper kind of helps to solve those vibrations. If you have the budget, absolutely do both. But if you have to pick one, I would probably pick the ATI because it's kind of solving the cause versus solving the symptom, if that makes sense. So if I was building one, I'd probably do both. But it's kind of cause and effect, if that makes sense. Did that answer the question, Mike? I kind of got off course. Yeah. So my brain goes in strange directions with all the technical stuff. More questions?
What's a crank scraper?
What is a crank scraper? So, I don't have a crankshaft. Oh, no, there are crankshafts. Let's go look. Hey, look, engine parts. So, here's a crankshaft. And here's your counterweights on the crankshaft. And the crankshaft goes...
How was that again?
It goes... In the crankshaft, you've got all your oil splashing around inside of your oil pan. And, the oil is just... It's all messy in there and splashing around and developing on here. And, it's sticking to the crank. And as an efficiency thing, what a crank scraper does, basically it forms a little barrier around the counterweights here. And usually what will happen is has a little Teflon scraper. And you set it up just right for your engine so that it's just barely, as the counterweights come around, it's not quite interference, it's just right there, and it's collecting all the oil, because as this spins, you've got centrifugal force, and all that oil is kind of moving out to the ends of your counterweights and just kind of adding some weight and adding some resistance. And when you're talking about really high RPM, you want to do everything you can to try to make your engine's life easier. So you're removing that little bit of extra oil that's kind of accumulating on there so that the crank can just spin a little bit more free because it doesn't, have all that oil that's kind of freeloading on there and slowing it down a little bit. I mean, this is super icing on the cake, but that's what it does. And another benefit to a crank scraper is you can, we do this all the time in the RX-7 world, not so much with the BPs, but you can also do an oil baffle that the crank scraper is kind of integrated with potentially, so that it helps to separate the oil and help keep it from getting aerated around the oil pickup. Because when the oil comes back down, it's really frothy and aerated. And if you do a separator panel there, then sometimes it can kind of catch that and let it de-aerate a little bit before it goes down in the sump, so that you have less chance of the oil that your pickup tube is pulling off of being aerated, because that's not something you want. So, yeah, good enough. All right. More questions?
Yes.
Mike with the light.
So, another good one that popped up here is a V8 swap cheaper than a four-cylinder, a built four-cylinder?
So the question is a V8 swap cheaper than a built four-cylinder? The question is yes, if the swap is you're selling your built four-cylinder and then buying a C4 Corvette. To swap one in a Miata, absolutely not. Between a built turbo four-cylinder and an LS built V8. Now, I'm speaking to what we did here at the shop. We did everything in the best way possible. We don't take shortcuts. We did everything to how we would want to do it if this was our car. And to say, for example, I want a 400 horsepower Miata, right? Which we've built a lot of 400 horsepower Miatas over the years. If I want that to be a turbo car, I'm looking at a stroker, a big turbo kit, all the things to make it as reliable as possible. With the exception that you're still probably going to blow transmissions because that's kind of always been an issue, and there's a long history there that I won't get into. I would say if you were calling me and saying, hey, we wanted to do that, and this was years ago when we were doing that, you'd probably be looking at, I'd say $30,000 to $35,000 to build a properly built, everything you need to be reliable, 400 plus horsepower turbo car. To get to the V8, to do the same thing, a properly built, reliable 400 horse LS3 V8, which is, by the way, going to have a very, very different power band, despite that 400 horsepower number. That would be probably on average around 60 grand. So double. Yeah, to get that horsepower level with the V8 conversion, it's about double because it's wildly more invasive. There's just a lot more going on, and you're replacing everything at that point to make it, safe, et cetera, et cetera. So if budget isn't an option, that's another story. And the nice thing about doing the turbo builds is you can do them in stages, whereas with the V8 builds, it's all or nothing. But with the turbo builds, you can do them, you can start a little bit, you can do a little bit more, you can do a little bit more. You can do it all at once if you can write one big check. But if you can't write one big check, you could have a 5-year plan, and you could really build it out so that you could amortize your costs, and you could make a larger horsepower turbo build more attainable, for the average guy who just doesn't have a whole ton of cash in the bank, because you're doing it smart, you're having a plan, and you're doing things in a well thought out progression to get to that long-term goal. Really, time is the key here. And I've talked about that in other videos. When you work out that mapping for your long-term goals, one of the key elements, if you have an income, you'll make the money over time. The key is time and having that plan and having the willingness to put in that time to get to your end goal. So, one more question, Mike?
Are there any engine modifications a DIYer could do in their garage for a street car?
So any engine modifications a DIYer can do in their garage for a street car?
That are worthwhile.
That are worthwhile. That last sentence is the tough part. Actually, the first time I rebuilt an engine, I did it in my garage, which is interesting. I actually started the rebuild process, and then I went out of town. And when I came back, everything was rusty. So I had to clean a lot of stuff. Well, okay, the aluminum wasn't rusty, but all the iron stuff was rusty. So, moral of the story, remember to oil and bag and tag your iron stuff if it's going to be sitting on a shelf for a while. What you could do in a garage, I did my own porting, and this is, when I was in college and I was figuring all this stuff out, I did my own porting and polishing in the garage with a Dremel. I just cheap, and I'm sure there's a ton of guys that have done this. You're not going to do machining work. Obviously, you're not going to do overbores and valve jobs and things like that in the garage, but you can do porting and polishing. Is it worth it? It depends on how it makes you feel. If you enjoy doing it, then yes, it's worth it. If you're doing it to get 4 horsepower, it's probably not worth the work involved to, give yourself a DIY port and polish job in your garage. But if you like to tinker, if you want the experience, then yeah, it could be worth it. So that gets back to being honest about, what is your why for what you want the car to be and what you want your Miata experience to be like. Because everybody's different. Some people over the years I've learned, some people take pleasure from racing their Miata. Some people take pleasure from building their Miata. Some people take pleasure from just researching things and not ever actually doing anything. Some people take pleasure from watching other people race Miatas. And all of those things are legitimate. And, it takes all of those people to develop the community. So what's your why and that? And, where do you fit in the Miata community, as far as it takes all kinds for us to have this thing that we can all take enjoyment from. So, because if every single person was racing, it would be a lot less fun than if we had all these other people around supporting us too, right? So I think that's pretty good for today. I've been talking a lot. I really appreciate all you guys tuning in, and for anyone that we didn't get to their questions, leave them in the comments. We'll get to them when we can, or when it ends up on YouTube. This will be sticky for a long time on YouTube, so try to get to comments there in the future. And if you have specific questions, just remember you can always reach out to our customer service guys, support@flyinmiata.com. We know we're always backed up. Apologies in advance, but we do care, and we will get back to you as soon as we can. And also, we are working on building up that knowledge base at help.flyinmiata.com. That is getting bigger every week, and we're really trying to download our decades of experience into something that's more quickly reachable for people that want some of that information. So thank you so much for watching, and we will always appreciate you guys being here, and hope to see you around. Thanks. Take care.